Very good evening, friends. Welcome back to the session. So today we are going to understand how neural network is helping us to find the strategy to predict the demand in the hospitality analytics. So let me recall what we have seen with respect to machine learning, what algorithms that we have defined, and later we'll move on to the neural network. So first we tend to understand what is the application of machine learning as well as AI, that is neural network, with respect to the hospitality analytics. And the second, we started understanding what is the program project methodology, that is CRISP MLQ, with different steps that we follow to deploy the model from first to end till the end. And then we'll try to understand what is EDA, that is data understanding and data pre-processing and analysis of data. And later we started understanding about some of the machine learning model like clustering. We started understanding K-means algorithm, and we started understanding classification algorithm. So classification, in that we have seen KNN algorithm. And then we try to understand the regression. One of the regression algorithm that is helping us to understand, that is simple linear regression. And then again, we started understanding the classification model, that is a decision tree. So after that, we tend to move towards artificial intelligence, that is neural network, which is helping us to understand how prediction can be done for classification analysis. Okay, so here we are using neural network, artificial neural network. So that will be created with some basic requirements to understand before getting in details of things with respect to neural network. Now, we'll just talk about neural network. So basically, when I say neural network, we heard two things. One is neural and another one is network. Now, why this word came into existence and what made this neural network came into picture? When we already have a traditional machine learning model, why we are moving into deep learning? So when we discuss about traditional model, we tend to design our data and then send it to model. That means we do perform EDA and then we'll make the data set ready. That will be splitted into train and test. And the train is sent to the model. And later it is sent to the test is sent to the model to test the accuracy. Test the accuracy, and the train is for to train the model. That trains the model with all possible features. Now, it's left to a user or a programmer. It is left to a programmer to decide whether the model should learn with respect to classification model with some parameters. So we call that parameters, whatever we have in KNN, we do have K value. Okay, so in K means we also have K value. So these parameters are manually set, and we also have some settings to make that prediction of the values, but still it is giving us some of the accuracy percentage, that is all about 92%, 93%, 90%. So like this, although regression model as well as classification model, and also the unsupervised learning model, that is clustering model. Okay. So now what happens is this is going to learn one time because my model is trained for the particular data and it is going to understand only those patterns. If there is any change in the pattern, so then there won't be any learnings. Again, the model needs to learn that particular data and then get trained and then need to find the accuracy level. So this was a big disadvantage sometimes because when the data is getting changed or when you want to improve the accuracy level, you need to every time change the hyperparameter values. So I'll call that as hyperparameter values. Hyperparameter values. So these values, whatever we have, is manually or some simulation with some calculations we are going to set. And based on this, we used to get some accuracy levels. However, there was a point where if there is a model, learn or get trained by themselves, then the accuracy can be improved. So where we can reduce the loss. So this was the basic scenario for deep learning. So even in deep learning, there is two things. One is deep and the another one is learning. So let me give you one simple example that for deep learning. So whenever you learn the topic, new topic, which you haven't come across, first time it will be very difficult. Or let's say it's example, very, very difficult. Second time when you are learning, the percentage of difficulty reduces and it becomes very difficult. Third time when you are learning, I'm talking about the same. I'm talking about the same topic when you are learning for the first time and second time, and this is the third time. Third time it will be difficult. Now, human tendency that we are sure that when we practice more, the fourth time it will be easy because we are learning the same concept. So the data set, when we pass the data set multiple times through the model, so it is going to run and give me the output as accuracy. Let's say example, first time it learned and give the 90%, which was very difficult. Difficult level was high. Okay. So next, when you go back and then make your corrections, because when I say you're giving a accuracy of 90% means there will be a loss of 10%. So it means to say that you need to learn from this loss. Okay. So when you go back and then make your corrections and again you make your model to learn, it obviously increases by 1 or 2%. Let's say example, it has been increased to 92%. So now the second time 92%. Next, the error rate is 8%. Okay. Now next time when the module increases, module repeats, again go back and then increases, again studies and again learn, then the model improves with 1 or 2. So like this, you can repeat your learning things. So you can set that hyperparameter to make your model learn as many as times so that you'll be getting some accuracy level. So this concept basically came from human being. The idea behind developing deep learning or neural network, we can call that as both neural network or deep learning, one and the same. So this concept is a basic idea of human brain or human being, where brain works like when a child, newly born child, he sees cat or a dog. So we as a parents explains the features of cat and dog. So whenever the child sees cat for the next time, it will say it is cat. If it is saying dog, if it is saying that it is dog, then the trained whatever you have trained the child with the features of cat and dog has failed. So what you do, again, you take a child and then tell the child that these are the features of cat and dog. So next time the cat will be predicted as cat by the child. So improvement will be there whenever there is a new learn. So like the same, we in our hospitality analytics, we have a data where we need to analyze and predict something. So when you are predicting, your accuracy should be as much as high as possible. So when we perform a prediction for a given data, so the data completely will be passed through the model with some notations and perform some calculations and get me the output. So this is my output. Now, how does it do? How does this model is created? What is the input that will be sent? What is the output? What are the calculations part that is done inside this neural network? How it is done? What are the hyperparameters that will be used? So that we'll see under this neural network. And then we'll use hospitality analytics, and then we'll try to understand. So for every concept, for every problem statement, we can understand the neural network contribution and get the data very easier or get the results very easier. Let me give you one more example that machine learning and deep learning. Here, the data is structured data. Here it is unstructured data. The program or the data that can be worked by the model even for unstructured data. Even machine learning can also work for unstructured data, whereas it takes time, the efficiency is low, slow, efficiency is low, but it is faster, efficiency is high. So hence it has been more. So when I say structured data, it is of with respect to tabular column format, and unstructured data means it is of image, text, documents, audio, video, and so on. These are the unstructured data. So most of the 80% of the word consists of unstructured data. Either it will be in image or text data or document, audio, videos, like that. So we just need to understand from that particular things and then get the result. So when I give you a particular image, let's say example, it contains a man running 100-meter competition and he was about to reach the line. So you can understand easily this by the picture. Here I have not written the man running at some speed and the deadline. So I just explained. If this is an image, you can easily understand something from the things. That is your caption of the image. The caption can be given by looking into the image. So like this, you can understand from the data and then get the values done. Now, coming to hospitality analytics, the main data that they should be considering is the data is not linear, or even if it is linear, it can be fitted with non-linear model to the data. And even if it is complex, it works fine. So that is the capacity of neural net. So we have in neural network, we have input layer, hidden layer, and output layer. Like how a man, human being, has eyes. Through this eyes, object is seen. The object will be recognized by passing the features of this object through the eyes to the brain. Okay, so then from this, there will be an output saying that this object is some object. Let us say that it is apple. So if it is showed that through the eyes and shows that the brain recognizes that it is an apple. So it is going to recognize that with the help of the features. The features are extracted from the or given as a input, and in hidden layer, it is going to calculate. So it is going to get the summation of all the inputs. Let's say example, this is x1, x2, x3, x4. So according to me, whenever there is a table, you'll be having table columns x1, x2, x3, x4, and y. So these are the columns. So each column is referred to be as input. And you can see that the connection, the lines, so these are referred to be as weights. So whenever you see a particular object, the object will be information. The object information will be carried through neurons or nerves. Hence, the particular information carried from eyes to the brain is nothing but neurons or the nerves. So here also, there will be a carrying from input to the hidden layer. So we call this as a weight carrier, weight. So there is some intensity. Okay. So this weight will be summation with the input, like this, summation of xi wi, because we don't know what is the size of the input. It can be, here it is 4. So x1 w1, x2 w2, x3 w3, x4 w4. So this is your summation. Okay, so for every node, you will be having a summation. After getting those summations, you will be having an activation function. So this activation function will be used for calculating some of the result, whether it is providing you or exactly what features has been extracted. So activation function is used to get the desired result from the extracted output. Let's say example, we have 2 plus 3 equals to 5. So how do you validate this? How do you validate this? We know the addition operation. So addition operation. So considering 2 and 3 both and performing addition operation will be 5. So this plus will be your activation function, and it will calculate also whether you are getting 5 or not. So you have different activation functions like softmax, sigmoid, tanh, and step function, relu, elu. So like this, you have plenty of activation function that will be used for any couple of changes with respect to what you are having the change or given as a input. So then after getting the activation function, the value will be forwarded to the next, that is output from the hidden layer. So this function will be again having a weights. So here the weights are randomly assigned. And here one more thing that you need to keep in mind, that the weights are assigned randomly. The values will be ranging from 0 to 1. It is not beyond that 0 to 1. Okay. So once you got here as an output, so output will be your probability. So whatever the output that you got is your probability. Let's say example, you are doing a classification and saying that it is cancerous cell or non-cancerous cell. If it is cancerous cell, then it will be prediction of 98%. If it is not, so from this, we can easily understand that you are getting cancerous as 0 and it is 1. So if you are getting an output as 0 and here it is 1, and this will be your 98% and this will be your 2%. So we understood that the feature or the input, whatever we got parameters, that is similar to cancerous cell. So like the same, when we consider our domain, that domain is hospitality domain. Hospitality domain. In this, we have market segment. So we just need to understand based on the room type, and their categories. So we'll see that in the hands-on, the categories. So using this, you will be getting either this, what is the market segment that is used, is booking the, are predicting the demand and bookings of the hotels. Okay. So let's say example, you have offline and online, groups, on spot, and corporate. So from the given input, whatever the input based on the room type, ADR, arrival date, arrival time, and stay, number of children, adults. So based on that, you'll be getting these values. This is my output. So let's say example, offline, I'm getting 50%. And online, I'm getting 10%. And groups, I'm getting 5%. And on spot, I'm getting 3%. So how much? 50, 60, 65, 68, and not 68. This will make it as 5%, 50, 60, 70, and this is 30%. So from here, I can understand that 50% it is showing or relevant to offline. So that means whatever the features that you have given, the input features that you have taken is relevant to market segment that is offline. So we can improve this understandings or the probability by making your model run number of times. So we call that as running the number of times as epochs. We make all the data pass through the model and get the values percentage, okay, the accuracy level. And you go back, when you go back, you will update these weights. So these are the weights. These are the weights that you have taken randomly, which you have taken randomly. Okay, these weights have taken randomly. When you are going back, you are supposed to update these weights. Why? Because based on these random values, that is based on these weights only, when you have given the input, that is x1, w1, when you are multiplying this, you will be getting some activation value, x1, w1. So this will be again with w4, let's say example. So you will be getting x1 out. So this x1 out will be multiplied with again w4 and you will be getting output at, okay, so output 1. So now we can't change the input. We can't change the input. So we just only need to vary this particular weights. Okay, so we can't change the input, hence we are changing the weights. So in what way the weights should be changed with respect to the loss that you got in your output. So you'll be getting 98% here and you'll be getting 2% here. Initially, if you are getting like so, then it will be output 1 is the output expectations that you are performing on the model. But if you are getting that as a loss, so when your loss is high, that means why I'm telling loss is high, because in our data we already have a data set with the output saying that that particular market segment is offline. For that particular observation, you can say that the particular offline, it is a market segment offline, but I am predicting that it as a online. So there will be a difference. This is your actual data and this is your prediction data. So prediction data minus actual data will be your loss. That will be your error. Okay, so we just need to predict the same what you have as a actual value. Let's say example, if it is offline, you are also supposed to predict that it has, the model should be predict as offline. Only then it will be accuracy level of the particular model. Let's say example, you have 10 observations. Okay, 1 2 3 4 5 6 7 8 9 10. So all these observations, it is giving you some actual values and you are going to have the prediction values for the same. Okay, so this is offline, this is online. Now this is offline, this is also offline, this is online, this is also online, this is online, this is also online. This is corporate, this is also corporate, this is corporate, this is also corporate, this is direct, this is offline. The prediction, that's a prediction. Okay, and groups, it is a groups. Okay, and it is online, this is also online. So now there is two changes, direct as predicted as offline and here offline as predicted as online. So out of 10, 8 were guessed correctly. That means your model is 80% accurate. So when you make you again learn, this can be converted to offline. When you make your model again to learn, this online becomes offline. So it increases by 10%. Now, again, when you make your model to learn, then this offline will be direct again. So it may increase. So you can also learn from this, right? Whenever we make your model to learn number of times by passing the same observations multiple times, the accuracy level increases. That means it is learning. So when you are doing such repetitions, you will be keep on updating these weights. So which you are understanding, which you are supposed to understand. So that particular weights will be adjusted with respect to the loss that you are getting at the end. So here, what is the loss you are getting here? Offline, and this is predicted as online. So there is a loss. Okay. So based on that loss, you are supposed to understand what is the amount of weight that you need to adjust. Okay. So this is one thing in the neural network. So it will be prediction. It will be predicted accuracy, so that the classification model what you are using will be based on all the hyperparameters. So here the hyperparameters are nothing but we also use some constants like learning rate. So the rate at which the model is learning rate, and also weights. And also we use, as I told you, activation function. Even at the output end, even at the hidden layer, we are not using at the input end. So activation functions will be used so that it will be giving you or guessing you the desired solution or the value, so that you will not lose any features that you are going to extract from the input. So it will be learning. Okay. So this is all about neural network. So this you need to be aware, because we have a time constraint to understand what is all about neural network. So hence we are understanding this much as a basic level. So if you want to go in depth, you just need to understand artificial neural network. Under AI, artificial intelligence, we need to understand artificial neural network, convolutional neural network, and recurrent neural network. So these are the main important things when you come across deep learning. Okay, so now we try to understand our data, and then we'll predict how much it is predicting. So we'll go back and we'll take the data. Okay, so these are some of the packages that we do required we use. So we'll come to know. So here I'm using pandas to read the data from the CSV file, that is hotelbooking.csv, and I'm printing the first few columns to display to understand. So these are the columns and the data with respect to. So in this, I just need to understand plenty of things. What is the mean value? What is the maximum value? What is the minimum value? What are the number of rows and what are the number of columns that we have? So like this, we need to understand those data. So for that, what we have is describe. Okay. So this describe will give you all the information that is with respect to numerical calculations, only with respect to numerical calculations. And next, we'll try to understand the information. We get to understand from the information, like the data that we have here is data frame in the form of data frame. That is with respect to tabular format. Okay. So here, what I have is the data which is in tabular format will gives you what is the type of the data that you have used, whether you have used numerical values, whether you have string values, whether you have used Boolean values, whether you have used zero, whether you have data or not a data, all the information will be given in this. So before doing any neural network, the data should also be processed or pre-processed, what I can say. We call it as exploratory data analysis. So we just need to understand the data, analyze the data, and we prepare the data for using before using the model. So here I'm using 36 columns and 1,19,389 rows observations. So these are the things. Here also we can understand there are some of the missing values. Okay, this gives an information how many missing values are there, how many values that is more important, what kind of values that you have, all the things that we can understand. So here data frame. So we already know that the data can be converted to data frame that will be easy for calculations. With if it is rows and columns, it will be easy for us to retrieve the data, do the calculations, and then perform the task. Null values. So when I say null, I'm using it with respect to dictionary where all the null values will be under null value key, and the percentage null values will be like calculating the percentage. So when I run this, I'll be having two columns. One is null values, one is percentage null values. So if you have null values, what percentage of overall data that you have, it will be calculated. You can see that for 488, it will be giving 0.4%. So when I have a data with a null values of 1,12,000, almost 94% that you have a null value in that particular column. So when you have a missing data, it should not affect your accuracy level. But because here company doesn't matter, you don't need that to be, even if it is null value, even if it is the column is not there, that doesn't matter because that is not the parameter that we are using for calculations. So we just need some of the columns that is pretty much required for calculating the values. Hence, we do require these uh, uh, understandings. Okay, so this is one of the important things that we need to have. Understandings of data. So here we just need to calculate what is important thing is we just need to fill that particular null value if it is having fill null value. So if you have that null value, replace that as with 0. So you just need to visualize your data. So this is one of the kind, and this is one of the again exploratory data analysis that we have to understand, and we read the data. What if in case the data contains here you have in the data column you have children, adults, and babies. So there are few columns which is saying 0. So we don't need that zeros to be calculated and used in the neural network. So for that we'll remove and make that as another data frame, that is filter. So when you separate that, we'll get a different data set. That is my DF again. So again, like it's like a analysis of the data. What we have done so far is data cleaning. So data cleaning is different. The exploratory data analysis is different. So first we need to clean the data with considering all the information, describe and checking whether it is having a null value or not. So hope all these are cleaning the data. So you just need to clean the data before you analyze the data. So now we need to analyze the data by having some calculations or graphical representation. So now we'll see how much E is cancelled half. If it is 0, then you have a value counts with respect to country and reset the index. So the country that you have number of guests will be given with respect to country wise. You can see that each cancelled is 0. Country wise, we get that column name as country and the second column name as number of guests. So you can see that you'll extract only two columns, that is country and number of guests. So it will be counted and reset the index 0, 1, 2, 3. So it will count the value. Okay, so this is to understand from where the people are booking, from which country the bookings are more. So we also have some graphical representation that will be done to understand how it is going to look. So this is one of the graphical representation. We use folium.map to map the particular data. And now moving on to the next. So we have a box plot which helps us to understand what are the number of outliers, whether it is normally distributed or not normally distributed, and we just need to analyze that particular things to use some of the other techniques to avoid those outliers. So we have two things, one is resort hotel and one is city hotel. Based on that, the data has been segregated with respect to two variables, that is ADR, average daily rating, and reserved room type. Okay, so with these two data, the graph has been designed. Now here we have two things, one is resort hotel and city hotel. So we just need to extract that resort hotel if it is city hotel, and how many we just need to group by based on the arrival date month and the mean of that average, taking average of that with respect to ADR as well as arrival date month. So if it is April, 75%. Okay, that is a mean value. That mean value means average 75%. Okay. Next, it is in the August 181. Like this, you have different months having different mean value. And for city, also you have the same mean value. And for a hotel, final, you are supposed to merge both the models, because finally we just need to understand the hotel. Even if it is a resort, even if it is a city, you just need to finalize that as a hotel. Now, next, after that, we just need to analyze with respect to month wise the price prediction. We are just to understand the prediction strategies, making the strategies based on the price prediction. So for that, we just need to sort the month with respect to price of the resort and the city hotel. So you have the price of the city hotel here, price of the resort and price of the city hotel. With the same, you pass that and make it as final prices. Now, the same final prices will be plotted with respect to the city values that you have and the month that you have. In first month, in January, in February, in March, April, like that, you'll be having. So you can easily understand that the graph has two line graph. So one is resort and one is for city hotel, which is telling a lot here. Okay, so we'll try to understand that. So resort guest. So we have two things in resort and city hotel. We also need to understand what is the resort guest and what is the city guest and final guest, merging those two. So same thing what we have done for city hotel and resort hotel, merging that and finally getting the hotel. So here also guest column. So why guest is required? Because we'll get the market segment, we'll get the room type that they have blocked, and we get the average daily rating. Okay, so here also you can see that we got from the number of guests in the resort and city hotel. So now So we filter that and then we get the number of stays in the weekends and weeknights and total nights. This is an optional. You can ignore that right now. So after that, we just need to rename the particular columns by getting number of stays. City hotel has more staying or resort hotel having more stays. So that you just need to understand that. And from that, you can easily understand that you have city hotel with total number of nights and stays increased. So even by plotting the heat map, Seaborn under heat map, you can just analyze. And this I have already showed you with respect to KNN, SVM when we were discussing. Same thing, repetition. I'm not taking any other new data because I want to uh, proceeding further, need to understand which algorithm is working well with my data. So for that reason, we are using the same data set. So we just need to understand the correlation between the cancelled values and the values that you have with respect to uh, correlation values. Okay. So after that, I just don't need some of the columns. So for that, what I'll do is I'll remove all these columns that is not required. Waiting list, year, date, year, room type, booking changes, reservation, country, phone number, credit card name, email ID. So all those are not required. Hence, we remove it with respect to column wise, not with respect to row wise. So after that, we'll have a category list, category columns where the category columns is of data type 0. So for that, what we'll do is we'll just have these category columns, that is hotel, arrival date, month, meal, market segment, distribution channel, reserved room type, deposit type, customer type, and reservation data type. Okay. So based on that category columns, that will be fed into category data frame, because you can see that all these are category columns. One or the other way, it is categorized based on different things: hotel, city, and resort. Arrival date, month, Jan to December. Meal, buffet, meal, plate meals, full meals, like that. Market segment, you have direct, corporate, online, offline groups, like that. Distribution channel, direct, corporate, TATO, and like that. Reserve room type is A, B, C, D, E, so on. Deposit type is non-deposit, no deposit, or deposit. So like this, you will be having categories. Hence, I've made it as these columns to be categorized data frame. So after that, you have again categories that is compared with the date time for with respect to reservation status, and year, month, day has been extracted. So after extracting that, we don't need reservation status because all the things has been extracted with respect to date, month, and year. Because in this particular last column, you have status date. So 2015 7/1. But if it is like this, then we can't able to understand. So what we make is date, month, year, will split that. And we'll make 3 columns. Here you can see year, month, day, 2015 7/1. So again, this is also a categorical data which is updated in the categorical data frame. So after that, if you list all the categories under this, you will be getting like this. So for that, I'll be using for loop for going through all the columns of that particular, and it will be separately saved in the list. The unique values will be saved in the list. So for that, every categories you will be having these values, and I can map to the same. If it is 0, then it is resort hotel. If it is city hotel, it is 1. So like this, I've made it as 0, 1, 2, 3. You can see here, all the things has been changed. I've not changed for month and day. So apart from that, earlier I used to get all these data as categorical data. Since I'm using for classification model, I'm changing those categorical numerical values, because I'm using artificial neural network where it considers only the numerical values, not the uh, string values or the alphabetical orders values. Okay, categorical values. So for that, I'll be using this. So now you need to drop some of the columns, that is categorical columns that you have. What are the categorical columns that you have here? You can see here you have here these values. These columns can be dropped because you already done with the uh, uh, exploratory analysis. We got the values, so hence we drop that particular columns. So after dropping that, we'll calculate one of the variance for that particular data frame. And here also we have with respect to time, arrival date, and the company ADR. So for everything we can calculate the variance. And with respect to ADR, if you have null values, you fill that particular with the mean value. That is the meaning. So whenever you have a particular column with empty cell, we'll fill that with respect to mean or median, just to avoid the outliers. Okay, so that is the concatenation that we have done. Now, my data is ready now. My data is ready with all the columns and the data set without any null values. Now I'll just make them as a different categories like test data and train data. So 80% of the data will be, 70% of the data will be your train data, and the 30% will be into test data. So that is have decided. So you can also decide with respect to 80-20. It is you can do it. Okay. So now I'm using Keras. That is important for deep learning. Important package that is helping us to create your deep neural network, deep learning. So for that, we just have categorical data frame and numerical data frame. We just need to concatenate that. We just need to collide that. If wherever you have two, what do you mean by that two? Let's say example, full meals. What is mean by 0? It is half meals. So like this, you just need to concatenate, join that, and then need to understand that particular data having the similarities. Okay, numerical as well as categorical data. So if you have any categorical data is cancelled, we have taken it as output. So you are taking this as an output and is categorical. So that is cancelled. Now import keras.layers and keras.models. So this is the important packages that we are making our model deep learning neural network model. That is, I've told you, right? You want input, you want hidden layer, and you want output, and these to be connected like this. So this we call it as dense network because it is completely connected. So when I say dense network, it is completely connected. Okay. So sequential model. That means first input, and the next is hidden layer, next is output layer. So there is a sequence from input to hidden layer, layer to input. It is not like output to hidden to input. That is different case. So not input to output and output to hidden layer. So there should be some sequence. So for that, we use the model as sequential model. So once you get that particular sequential model created, we add the particular values and we pass the input data. Okay. So now the model is with 100 neurons at the input. So we have given 100 and the data input shape is taken as 26 and 100. So 26 and many. Okay. So this is a dimension that they have taken. You can just also change. Okay. The activation equation that they have taken here is JLO activation function. This is efficient activation function for all the classification model. So here I'm using at the output layer. So this is my input layer. This is my hidden layer. This is my output layer. Okay. In the output layer, I'm using sigmoid function because we need either 0 or 1 as a categorical data. Either it is booking or not booking, either it is canceling or not canceling. So we just need to those things. Hence, I'm using sigmoid activation function. Now, you also need to calculate once you get the output at the end, you just need to validate this and get the what is the error that you are getting. If you are getting some error, I just need to adjust this error by making our model again learn. Okay. So we just need to calculate this particular error with respect to binary cross entropy because we have two things. One is either cancelled or not cancelled, either 0 or not 0. Okay. So for that, I'll be using binary. If it is having more than, you'll be using some other value, that is multi-class cross entropy. Okay. So now I'm using loss, that is binary cross entropy. So I've told you, whenever your model is created with a number of neurons and hidden layer and output layer, when you go back, you just need to update with respect to loss. So that will be taken care by optimizers. So we have plenty of optimizers that will take care to make sure that it is adjusted. The weights are adjusted with respect to the loss that you got at the output. That is Adam. Okay. So then you are making your model fit. That means compile and run that. Okay. So now your model is fit for X train and Y train. So here you can see that earlier I used to make my model with respect to X train and Y train, X test and Y test. You know this already, we have the data. So now the same data will be passed on to the model and it will be made to learn. So you can see that the model is learning. So these are all each step that model is learning. So you can see that accuracy is, validation accuracy is almost 98%. So how many times it has been executed? 30 times it has been executed. Okay. So when it learn 30 times, it is giving you 98%. So same thing, we can just draw the graph and then make use of learn how the data has been learned with the training data, and then we pass the same while using the test data. So this is all about with respect to train data and loss, the training loss and the validation loss. Okay. So almost it should be similar. Whenever you have a data with no outliers, much outliers, your training loss and validation loss will be same. Okay. It should be always same. Now, we just pass the test data. This is training accuracy and test loss validation accuracy. So two things you need to calculate for training and validation. So first you need to understand the loss, and the second we need to understand the accuracy. So both should be similar, same. Okay. So now we pass the test data to the model that you have already to evaluate. So evaluate the model and then test whether it is accurate or not. So when it is giving the accuracy model, it is giving you 98%. So even when you are training your model, you are getting 98% accuracy. Okay. So same thing while you are testing. So this gives you 100% that the data that what you have is perfect. So it is not predicting anything, but whatever the data that you have, let's say example, you have five rows. Okay. So here I have offline segment. Okay. Here I have online segment. Here I have corporate. Here I have offline. Let's say example, it is predicting offline. This is also predicting online. This is also predicting groups. This is corporate. This is also predicting offline. So it is almost 98 or 99% accuracy that it is predicting properly. So that is the meaning. So this is just a model selection and model evaluation. So we already know in the CRISP MLQ steps. first we understand the business understanding, and then later we understand the data understanding. Then we'll go with data pre-processing or EDA. Then we'll choose the model. And after that, you evaluate the model, then you deploy the model, and then you maintain the model and test the model. So these are the steps. So here, till here, we have seen this is all about with respect to the main portion. So later, when you are supposed to deploy, you can just use any of the cloud service and can deploy. Okay, so later we can just have the maintenance, because the data will be live stream data and it is getting every time changed. So this is all about with respect to your neural network concept with respect to the data that we have with hospitality analysis analytics. So you are getting 98%. So machine learning models and deep learning models, it is all about 96%, 95%, 93%, like this. Logic, linear regression, classification model, and clustering model. We are getting all these efficiency, and deep learning we are getting 98%. So hence it is efficient. So thank you all for your cooperation. So this is all about data analytics, that is domain analytics, what we are supposed to understand with respect to both machine learning as well as artificial intelligence. So please do subscribe for the channel, and then get all the information with respect to other domain analytics sessions. So you'll be getting upskill, because as a data engineer, you need to know what's happening, how to do with data analytics, so that it will help you for your progress. Thank you all. We'll meet in the next sessions.